My name is Madeline. I'm starting to get known as the robot whisperer. What I tend to do is to take these big, monstrous industrial robots and ask them to do things that they were never designed to do. But my journey to robot whispering has actually been quite circuitous. I am an architect by training. I'm not a roboticist. I'm not a scientist, not an engineer. I'm an architect. And from architecture to robotics, I've been called a lot of things: a fashion designer, a scientist, a researcher, a software artist, and a roboticist. And to be honest, I'm not really any of those things. I'm kind of those things, but not really any of those things. I pull from all sorts of different disciplines and techniques and take some good stuff from robotics and apply it to art. Take some amazing techniques from art and apply it to fashion. So what I thought I would talk with you guys today about is, what do you do when what you do doesn't really exist yet? When there's not a degree program you can go to and say, I'm going to get a piece of paper that says, I am this. How do you define what your next step is when no one else has kind of taken that step before? For me, what's my guiding light is just to have an insatiable curiosity for the world around me and a deep desire to see the future now. Those have been sort of the guiding gut feeling that has taken me along my journey. So what I thought I could do is talk about a single thread of an idea that I've kept with for a couple years. And I want to show you some of my work chronologically, and we can see how that thread of an idea has evolved and mutated and changed and has a life of its own, and how it's taken me from architecture to fashion to art, to robotics. So that idea, this idea that I'm totally obsessed with, is how to communicate with machines that can make things. So machines that make things are like 3D printers, laser cutters, industrial robots, all these things that you can take a workshop for today in the Fab Lab. How many people here have ever used a 3D printer before? Can I see some hands? That is a huge number. Oh, right, this is amazing. So how many of you thought it was super easy to use that 3D printer? Okay, yeah, a lot less hands, yeah. There's a lot of technical knowledge that you have to have in order to use this incredible machine, in order to talk to this incredible machine. And a lot of those complications come with 3D modeling and the geometry you have to use. There's tons of technical knowledge that you need to have before you can effectively 3D model for 3D printing. But why is that software so difficult? Why can't we embed some intelligence into the geometry itself? Because it knows it's going to get 3D printed. Why can't we embed that principles inside of it? When we're designing things for the body as well, it's extra complicated because we're designing in this empty space of a computer, but it's going to come out and live in the real world on something very specific. So this is a project of mine called Reverb. It lets you use your hand gestures to interact with this virtual squid that you can drape around a 3D scan of your body. So with a couple quick gestures, you can create this really intricate geometry that's sized to your body, that's ready to print and ready to wear instantly. So a lot of the magic behind this happens inside this virtual creature, this little squid. That's where I've been able to program in the intelligence of an experienced 3D printer, an experienced fabricator, and embed that into the actual anatomy of this creature that your hand interacts with. These are some things that I 3D printed. A lot of these were generated in 10, 20 seconds. They've taken much longer to print. They take about 30, 40 hours to print. But you can see when you put them on the body, because we started from a reference of the body, that it really hugs our anatomy quite well. This is made out of nylon. What was interesting about this process as well is that I didn't even realize, even though I made the software that did it, is that the density of the material, it's a homogeneous material, but the density of it gave each individual necklace these unique material properties, whether this one, for example, was springy, so you could pull it really far and it would connect back across the neck. This one would just balance delicately on the shoulders. And this one was quite squishy, actually. And you can see that we can create really fine detail where this necklace just barely touches on the body because we start from our reference point. So I was absolutely in love with the physical artifacts that came out of my machine, out of my software. But what I was not satisfied with is that I still had to have this experience mediated by a computer screen. I was so close to merging these digital and analog experiences, but I still had to look at a computer screen in order to do this. So for designing things for the body, there are some really amazing tools that are happening now for these virtual digital mannequins that are absolutely dynamic, that move with the body, but they're stuck inside the computer screen. And even the most talented of computational designers working today, they can reach some pretty creepy endpoints when they're trying to iterate and test out some of their designs. So if we're going to 3D print things for the body, why not just design them right on our body? With this project Tactum, it detects your interaction with your skin and lets you use those touch interactions to actually modify a 3D model. And then it projects that reference back onto the body. And just like the previous project, you can 3D print it immediately, and it's ready to fit, ready to wear. So let me show you how this works, actually. This is using a leap motion controller and a projector, and it detects your skeleton, and from there, I can extract where your wrist is. I put some interactive geometry, just like the squids, actually, the same basic principles, onto your arm. And using that same sensor, I can begin to see where your finger touches your arm, because it can sense depth. So here we can see, this is just to go a little bit behind the scenes here. What you see on the top there is actually an Xbox Kinect. It's a $50 sensor you can buy in any electronics shop. So the technology behind this is really cheap and accessible. And what I'm doing is I'm looking at what looks like an arm to that camera, to this machine, and tracking that around. And I'm just looking for the space right above the arm. And when a finger-shaped object enters that space, I know we have a touch. And with that simple technique, we can classify touches and versus rubs, versus pokes, versus pinches, and then you have all the interaction with the arm itself. These are all things that you can send to a machine, to a design program, to make this interactive geometry that you can 3D print and wear. So this is a smartwatch band that I made with the same app. So we can make very precise things as well because we have this physical reference for sizing things on our body. Okay, so I was really happy with the geometry, and I was really happy with the interaction here, that there was no mediation between a computer screen and me to create this thing. But now I wasn't satisfied with having to still go ship this to a black box 3D printer and wait a week for it to come back. And that's what got me started down the road of working with robots. This is a 6-axis industrial arm. It's usually used on manufacturing lines to create cars or to create planes. A lot of the vehicles that you took to get here, whether it's the train or the car, it was more than likely built by one of these machines. And what you can see here as well is that all of the robots are separated from all the people. When humans interact with these machines, it's really fairly dangerous. This is kind of state-of-the-art human-robot interaction, courtesy of a 1997 video on YouTube. And it's really for good reason. I am soft, squishy flesh, and these are hardened steel beasts of machines, and they're quite dangerous. So of course, I wanted to turn one into a masseuse so it could give me a back massage. So this is one of the first art pieces that I did, where this end effector, this thing on the end of the robot, has sensors in it. If you lean back, the robot goes a little bit harder to give you a massage, and if you lean forward, it goes a little softer. And that led me to go to the Pier 9 Artist Residency in San Francisco, where they had too many toys and not enough people to play with them. So here I am working with a motion capture system and a giant beast of an industrial robot, getting it to follow me around like a happy puppy. I'm really passionate about inventing better ways to communicate with machines that can make things. For a long time, industrial robots have been the culprit of automation and replacing human labor. Basically, all the easy tasks to automate have been automated. Now what we're working on is using these tools to enhance or augment human labor. And that to me is very exciting. Industrial robots are really fantastic CNC machines. You put a different tool at the end of the arm, and all of a sudden they can do a whole different thing. So in the morning you can be doing spot welding, in the evening you can be doing painting. It's just highly adaptable. Another thing that I'm really working towards is finding ways to bring these machines out of factories and into live environments. So onto construction sites or onto film sets. There's chance for unpredictable objects like people to be moving into the environment. That's one of the reasons why I wanted to build the system, to give this robot eyes so that it could actually see me and we can safely collaborate in a shared space. If I'm wearing or if I'm holding these motion capture markers, it knows where I am in space, it knows how I'm moving in space. Now all of a sudden we can give the machine a nuanced understanding of our intention in that space. You can get someone who's never seen a robot before and have them begin to do creative things with just a couple minutes of interacting with the machine. Finding ways to bring in digital design and fabrication technologies to that could be monumental if we can figure out how to do that safely. It's really an amazing benefit of being here in Pier 9. It is physical space and the mental space to just experiment. And it's been really fantastic to have the freedom to question how we do systems now and push the boundaries of what's possible with robotics. So that was about a year ago, and since then I've been playing with smaller, more agile robots with the same technology, same motion capture. But again, how do you get people who have never seen these highly technical machines get to do fun and interesting things like this, like playing with my googly-eyed friend here? And there's a lot of possibilities for these small robots, but at the end of the day, these monsters are awesome. They're so cool to play with. This thing that could potentially crush you and that you're inches away from. It's just intoxicating to be close to. And that, as Ollie mentioned, that's what's brought me to London. I got a call from the Design Museum to say, hey, we saw what you were doing over in San Francisco. Can you bring that into our museum? And I said, sure, yeah, no problem, it's easy. So we've brought a 2-ton industrial robot into a museum and transformed the experience so a crowd of people could begin to play with this robot and see the potentials of this machine if we had more fluid means of communicating with it. So the exhibition is called Fear and Love, and it's really getting at every artist who's there is tasked with thinking about how we address our fear and love and anxieties around 11 different topics. For me, it's automation and robotics. So this is Mimus. This is what I've been working on for the past 4 months in Boston. We, again, using really simple technology, we're tracking all the people around Mimus's environment and letting it follow them like a curious puppy. It's been a really incredible experience for me to begin to imbue personality and characteristics into a machine and to see how people who have never engaged this technology before are interpreting and interacting with it. So I hope you'll come see it. The opening weekend of the museum is on November 25th. It's going to be free for the first weekend, and it's in a brand new renovated, the Commonwealth Institute, which is absolutely a beautiful building. Just to wrap things up here, this thread of an idea, how to communicate with machines, is something that's taking me from architecture to New York Fashion Week to research labs across North America to London to chat with you guys today. And this obsessive passion has been a guiding light for me. And I hope that as you guys navigate this weird and unknown and complex future, that you can find a deep, obsessive, insatiable curiosity for the world around you, because that's what's going to guide you forward. Thank you.